Greetings and welcome to my new calculus channel. My name is John Gabriel. So, in this video, I'm going to talk about some very popular misconceptions in the mainstream. So, for example, if you have this curve here, which happens to be 1 over 1 plus x squared, this is this curve here, okay? It's 1 over 1 plus x squared. Mainstream academics will, in their ignorance, tell you that the area under the curve is pi. Well, that's just simply not true. You can't calculate the area under the curve. Does it have a limit? Yes, it does. And what is the limit? The limit is pi. But there is no infinite sum that will give us pi, okay? So a limit is not the same as an infinite sum. And this nonsense started with Euler in his Elements of Algebris, where he stated in Article 298 that S is equal to lim S. That's simply not true. Okay, so now popular packages such as GeoGebra will mislead you. Be careful. So we know that the primitive of this function here is the inverse tan function. If you put f with a little lopsided 8 in the function, this function here, you will see that it will calculate the area. Supposedly, the area under the curve is being pi. But that's wrong for several reasons. Well, first of all, the area between this part of the curve down here and the x-axis is negative. Okay, it's negative. And the area on top of the x-axis is positive. So if anything, the areas should cancel each other out. But because of the way the fundamental theorem is stated, this area turns into a positive value and you end up getting pi. Now, is there inverse tan of infinity? So what does inverse tan take? Inverse tan takes a ratio. Is infinity a ratio? No. Infinity is not a ratio. Is infinity a number? No. So it's utterly false to say that f of infinity is equal to pi over 2, right? F of infinity. Okay, so GeoGebra and other packages will tell you that that's equal to pi over 2. And of course, that's not true. Again, you have limits there, okay? So you see these lines. These black lines are asymptotes to this function, okay? So what they're doing is they're taking the limits, but this value really here is undefined. There is no f infinity. There is no f minus infinity, okay? That's something you need to be very careful of. And when you're evaluating something called an improper integral, which has subscripts that are not numbers like infinity, you're really looking at the limit. You're not really looking at a sum. For example, the area is generally defined as the product of two arithmetic means. But take this curve here, the green curve. There is no product of arithmetic means here. What would it be? Would it be infinity times something very small to give you the average value? It's just utter nonsense, okay? So when, for example, you calculate these areas, you're looking at a limit. The same thing happens with the normal distribution function when you're calculating probability densities. You're not looking at infinity. You're looking at a certain range, okay? That's the only reason that you have actual numerical values. But if you go supposedly from negative infinity to positive infinity, you have a probability of 1, which is absolute rot. You never have a probability of 1, okay? In other words, nothing is absolutely certain. And of course, in statistics too, on the one hand, they'll tell you there is no probability of 1. And on the other hand, they'll tell you that the sum of the area the total area under the curve is 1. That's where you have that constant 1 over square root of 2 times pi times the standard deviation. But that's just a load of rubbish. Okay, so you do not have infinite sums. You cannot calculate infinite areas. Let's look at another example. Get rid of those. I'm out of breath. I think I'm getting pneumonia. I hope not. Take a look at this curve. So this curve here is this particular function here, 1/3 times 1 minus 10 to the minus x. This here has an asymptote. Y is equal to a third. Okay. It doesn't ever touch it. It has an asymptote there. Now, the absolute morons, my intellectual inferiors in the mainstream who are mathematics professors and teachers, will tell you that you can put t of infinity there and you'll get 0.333 with endless threes. That's absolute rubbish. That's just not possible. Can you even think of a completed infinity? Because that's what this would have to be. It would have to be completed infinity. Don't be stupid. And now, here comes the lightning bolt, which just makes these fools look like even bigger fools than they are. You cannot measure 1/3 in base 10. It's impossible, okay? There is no way for you to state 1/3 in base 10. And that's because of the most important number theorem, which I'll place a link to in the detail section. So be careful if you type in T infinity and you get something like this. That's just absolute rot, okay? It's not this. So the limit is not the same as the sum. And you will find this, where students come out and they say, wow, Fourier series and Laplace transforms, they use these kinds of concepts. They don't. Okay, they use limits. And in most cases, if you do not have a primitive function, as we did in the case of inverse tan x and its derivative, which is 1 over 1 plus x squared, then you don't have anything. Okay. So 1/3 is decidedly not equal to 0.333 recurring forever. That's just absolute rot. Yeah, there's a pattern, but it doesn't go on forever because there is no forever. There is no completed infinity. Infinity is a 100% garbage concept. If you're not already a subscriber, become one. Click like because many people hate me and my channel and my ideas. And follow me on academia. I'm John Gabriel, and this is a new calculus channel. Till next time, goodbye.